Alright, hello everybody. We are going to get started with our 3.5 notes, which is for our radical equations. And we're just going to look at the first part of these problems today. So a radical equation is an equation that includes a radical. And a radical is a square root, a cube root, etc. A lot of times it's easy to mix up radicals and rationals because they sound very similar. A radical is a square root or root of some sort. Rational is a fraction. So whenever we are solving radical equations, you sometimes get what we call here extraneous solutions. And extraneous solutions are solutions that do not work in your original equation. So you have not done anything incorrectly, but when you plug the number back in, it does not work in the problem. So we talked about extraneous solutions just a little bit whenever we were looking at rational equations, and they were fairly rare. We didn't see them in a lot of problems. However, you're going to see extraneous solutions often with radical equations, so it's going to be really important that you always check your answers. So let's begin. Some of these are going to be super simple. So if you have a square root and you're trying to solve for this x right here, you just need to get rid of that square root, and to do so, you're going to square, because squaring and square roots are inverses. If you square the left-hand side, then you're also going to have to square the right-hand side. And so this will give you just x minus 2 on the left-hand side, and you'll have 36 over here on the right-hand side. So you'll just need to add that 2 to both sides, so x will equal 38. Remember, I did say it's very common to get extraneous solutions here, so you want to plug that number back in. And so 38 minus 2, of course, is just going to give you the square root of 36, which is 6. So this answer does work. For example 2, we've got a cubic here. And so much like our problem with example 1, we need to get rid of this cube root here, and to do that we are just going to cube both sides. So on the left hand side we are just going to be left with x squared minus 1. On the right hand side here we're doing 3 times 3 times 3, which is going to give us 27. So we will add 1 to both sides. X squared is going to equal 28. And we will need to take the square root of both sides. So x is going to equal, remember right here you want to put plus or minus the square root of 28. Anytime you square root both sides of an equation, you have to put that plus or minus sign. And 28 will break down. That's the square root of 4 times the square root of 7. So probably you're going to see the answer left like this, 2 square root of 7 for this. Now, I went ahead and circled that probably earlier than I should, because you do have to plug this number back in. So if you plug that back in, you've got cube root of 2 root 7 squared minus 1. And whenever you square this value here, you're going to square the 2, which is going to give you 4. And you're going to square the square root of 7, which the square and the square root are just going to cancel each other out. So that's just going to give you 7. And then, of course, you still got this minus 1 over here on the end. And then you've got the cube root of 28 minus 1, which is the cube root of 27, which is, in fact, 3. And that is what the answer is supposed to be, so you know that that is correct for the positive 2 square root of 7. If I go back here, if this was a negative 2 square root of 7, it's actually not going to change anything, because we still have to square the 2 square root of 7. And when I square that negative 2, it's going to become a positive 4. So nothing is going to change here if that is negative, so both of these are actually correct answers. All right, here's our next problem. Here we have a fourth root, and we also have something a little bit different on this problem, because this fourth root is not by itself. We've got this fourth root, but we also have this 2 and this negative 20. And so whenever we're solving an equation like this, we want to get that root by itself first, so then we can, in this case, raise both sides to the 4th power. So I'm going to add my 20 here. And so I'll have 2 times the 4th root of x squared plus 1,000 equals 20. I'll divide by 2. And so I'll get the 4th root of x squared plus 1,000 equals 10. Now, to undo a 4th root, I need to raise this to the 4th power. And so I will have x squared plus 1,000 is going to equal 1, 2, 3, 4, 0. We'll see. Not too many there. Okay. And so if we subtract the 1,000, we're going to get x squared equals 9,000. And we will square root both sides here. And let's see, if we're going to break down 9,000, let's see, it'd be 9 times 100 times 10. If I wanted to break it down that way, I could do 900, I guess, there. I'm just thinking of these in separate parts. So we're going to have x is going to equal plus or minus. Here, square root of 9 is 3. Square root of 100 is 10. So we'll have 30 square root of 10. Once again, I know it's a pain. I do not like doing this either, but you got to plug it back in to check. It actually is a little easier if you just plug the square root of 9,000 in. So if you do 2, 4th root of square root of 9,000 squared plus 1,000 minus 20 equals 0. So you got the 4th root of 9,000 plus 1,000 is going to give you the 4th root of 10,000. And the 4th root of 10,000 is just 10. And 20 minus 20 does equal 0. So that lets you know that this is correct for the positive. If you changed this and made that 9 square root of 9,000 negative, it's still not going to change the answer because you're going to get just a 9,000 here. When you square that, it's going to get rid of that negative. So both answers are correct here. So plus or minus 30 root 10 is our answer. Okay, let's look at this particular problem. In this case, we just have square roots on either side, and so all we have to do here is just square both sides of our equation. And so this is going to give us 6n minus 3 equals 4 plus 7n. And we want to solve this. We can do that by subtracting our 6n. So we get negative 3 equals 4 plus n. We can subtract that 4, and we get negative 7 for our n. As always, we have to check to see that this isn't the correct answer. So we're going to get 6 times negative 7 minus 3 equals square root of 4 plus 7 times negative 7. And so here we have negative 42 minus 3, which is going to give us the square root of negative 45. And over here, we're going to have 4 minus 49, which also gives us the square root of negative 45. Now, I would be inclined to say that that means this answer is okay. However, this is a question that came from our textbook, and our textbook says that because you have the square root under, the negative under the square root, that negative 7 is not actually an answer because you have that imaginary number. So they say that it is no solution. Because you have that negative under the square root. Okay? This is going to get into some problems that are a little bit different. Here, I'm going to square both sides, but in this case, I don't have a number on that right-hand side. I've got a variable. So whenever I do that, our answer is going to look like this. Negative 16 plus 10a equals a squared. So what happens here is we have a quadratic. So we're going to have to move everything to one side and solve this quadratic. So if I move both the 16 and the 10a over to the other side, I'm going to have a squared minus 10a plus 16, just moving those over to the other side. And then I want to factor because I believe this one will factor. And for 16, I could do minus 8 and minus 2. That'll give me positive 16 when I multiply. It'll give me negative 10 when I add. So each one of these are going to be set equal to 0, which means that I will get a equals 8 and a equals 2. Now, once again, you must check your answers. It's a pain, but you've got to do it. So here I've got square root of negative 16 plus 10 times 8 equals 8. And so this is negative 16 plus 80, which is square root of 64, which does in fact equal 8. So 8 is the correct answer. I also want to check for 2. So I'm going to have the square root of negative 16 plus 10 times 2 equals 2. And so I get negative 16 plus 20 equals 2. So square root of 4 does equal 2. So that one is also okay. Alright. Example 6 gets into the most difficult type of problem that you will see today. And in this case, you have a square root on the left-hand side, but you do not have a single expression on the other side. So you're still going to have to square to get rid of that square root. But when you do that, you are squaring the x plus 4 as a whole. Be careful here. This is not x squared plus 16. This means that we're doing x plus 4 times x plus 4. And hopefully you can do this in your head so you know that left-hand side is just going to be x plus 6. The right-hand side you can square the first, multiply these two together and double it to get an 8x in the middle, and then square the last. There. If you can't do this in your head, go over to the side. X times x is x squared plus 4x plus 4x plus 16, and that'll give you this expression that you have here. So we have another quadratic here, so we're going to subtract the x. We're going to subtract the 6 to move everything to one side. So 0 equals x squared plus 7x plus 10. And I believe this one's going to factor, so we're just going to factor this into x plus 2, x plus 5 here. And so when we set each one of those equal to 0, we will get x equals negative 2 and x equals negative 5. Once again, make sure you plug in your answers. So when I do this, I've got the square root of negative 2 plus 6 has to equal negative 2 plus 4. So that is square root of 4 equals 2. That is correct. So negative 2 is a correct answer. For the second problem, I have negative 5 plus 6 equals negative 5 plus 4. And here I will get the square root of 1 equals negative 1. Now this is not true. So what we have here is not a solution. This is what we call an extraneous solution. We did not do anything wrong. We did everything right, but that answer just does not work whenever we plug it back in. This happens often whenever you square both sides of an equation, because right here, where this was a positive 2, if you square both sides, it would also be okay for it to be a negative 1 after you square it, but of course it's not okay in the original equation. So watch out for those extraneous solutions. Okay, here is another problem that is very similar to what we just did. So we're going to have to square both sides. When we square this side, remember this is not 25 plus 4x squared. This is 5 plus 2x times 5 plus 2x. I would prefer that you didn't write it, that you just did 25 plus 20x plus 4x squared. Just did that part in your head, but if you need to, write it out. And that's going to equal x squared minus 2x plus 1. So we are going to move everything to one side. So we'll subtract that x squared, we will add the 2x, and we will subtract that 1, and I'm going to write this in order here, 3x squared plus 22x plus 24 is going to equal 0, and so we need to factor this, and it's not the easiest in the world to factor, so we could use a 6 here and 4 here. Will that work? We'll have 18 and 4. Yet that'll work. So we'll set each one of these equal to 0. So we'll have 3x equals negative 4, and so x will equal negative 4/3. This is one of our answers, potentially, and the other one is x equals negative 6. So whenever we do this, we do need to check our answers. Now, these are starting to get a little bit difficult to check. So let's use Desmos to help us a little bit here. So what I have done here is I have typed in 5 plus 2a. I used an a instead of an x because sometimes with the x's, it'll give you a little bit of trouble where x is a variable in the graph. And then I did the square root of a squared minus 2a plus 1 in the second equation. And so I'm just going to type in my answers for a equals down here, negative 4/3. And you can see that it changes these two values, and they are equal to each other. So that lets me know that negative 4/3 is an answer. And I'm also going to try negative 6. And you can see whenever I plug in negative 6, I'm getting negative 7 for this left-hand side, but I'm getting positive 7 for the right. So negative 6 is an extraneous solution, so we're going to throw that one out. All right, and this is our last problem that we're going to do. So for this problem, it's going to be really difficult if we square this as it is. It is going to make it a little bit easier if we go ahead and subtract this 4 over to the other side first. So we're going to have square root of negative 3m plus 10 equals m minus 4. And so now this looks a little like the other problems that we've done. We can square both sides. And so we'll have negative 3m plus 10 on the left-hand side. On the right-hand side, remember this is m minus 4 times m minus 4. So I'm going to square, double square. I'll have m squared minus 8m plus 16. And so we want to move everything to one side. So add that 3m and subtract that 10. And so 0 equals m squared minus 5m plus 6. We'll just factor this here. And we're going to use a negative 2 and a negative 3, which means we'll get m equals 2 and m equals 3 as our answers. Let's try that same thing with Desmos here that I did for the other problems. So we would say 4 plus square root of negative 3m plus 10. I'm going to use the m actually this time. And if I say m equals 2, I will get 6. 6 does not equal the m, which is 2. So 2 is an extraneous solution. And if I plug in 3, let's see, neither one of these work. I may have made a mistake. Whenever you're doing these problems, if both answers are extraneous, that can happen, but it should not happen that often. So let me pause here for a second and see if I can figure out what I've done wrong. And actually, I have gone back and looked at this. I do not think I've made a mistake anywhere. I even checked it with Photomath, and Everything is good here. I will tell you, if you have both of these extraneous, you do want to check this lots of times, because it usually means that you messed up. But in this case, it's not the case. So since both of these are extraneous, we would just say we have no solution. So I hope this helps you with your Delta Math assignment today. If you have any questions, let me know.